Morning, children. Okay. Yesterday I told you काही क्वेश्चन्स करायला सांगितले होती, करून काय कोण पाठवलेली नाहीयेत, त्यामुळे अजून काही क्वेश्चन्स मीच सॉल्व करेल. You can write down this question. Write down in your notebook. चला लिहून घ्या नोटबुक मध्ये हा क्वेश्चन. Find the current drawn by the battery and the potential difference between A and B. Find. Write down this question. चला लवकर कॅमेरा ऑन करा. Everybody keep your camera on. Question number 19 मी सोडवून देईल बेटा. I will solve it. Mayuri, I will solve that question. Write down this question. ज्यांनी सोडवला असेल उत्तमच, नसेल सोडवला help yourself. Help yourself. What is asked? Find the current. So how much is the current? Okay, given by this battery. प्रत्येकाने कॅमेरा इमिडिएट ऑन करायचा. सगळ्यांनी find the current drawn by the battery as well as potential difference. As I told you, this will be a positive terminal, this will be negative. Now they have already shown the direction of the current. So current will be coming, flowing through this, but at this point, current is getting divided. Some current is flowing in this direction and some current is flowing in this direction, means along this direction. Since there are two different directions and again they are meeting at point B. Again they are meeting at point B. Okay. So since current is getting divided, so I will consider that current as some I1 and the current through this side will be I2. We will consider this resistance as R1, this resistance as R2 and this resistance as R3. So at point A, current is getting divided. Therefore, R2 and R3 will be, or R will be in parallel. They are in parallel, or you can write R2 and R3 are in parallel. आता याच्यानंतर पॅरलल शब्द फक्त असा लिहिला जाईल, दोन लाईन नंतर EL, that is parallel. Okay, since these two are in parallel. त्यांचं इक्विव्हॅलंट रेझिस्टन्स अगोदर काढायचंय. You have to calculate the equivalent resistance. मी तुम्हाला सांगितलंय फॉर्म्युला RT ठीक है. So what is asked? Find the current drawn by the battery and the potential difference. So at point A, current is getting divided. That's why this resistance and this resistance, these two resistances, this and this, they are in parallel. Okay, त्याचा रेजिस्टन्स किती आलाय? So that is how much is the resistance? It is 10/3. Formula you already know. Equivalent resistance is RP is equal to product upon sum. Product means 5 into 10. कारण एक 5 आहे, दुसरं 10 आहे. Divided by sum, that is 5 plus 10. Now this will be in, so this is that RP. This is RP, which is 10/3. And this was R1, that was 5. Now what do you know? This R1 and RP will be in series. They will be in series combination. Therefore, final resistance, that is R, will be R1 plus RP. R1 is 5. RP is 10/3. So LCM, so it is 15 plus 10. Okay, 15 plus 10 upon 3, which is 25/3. Don't do calculations in between. आधे मध्ये calculations करायचे नाहीत. Okay, this is resistance. This is resistance. आता त्यांनी पोटेन्शियल आपल्याला दिलेला आहे सेलचं. Therefore, I is equal to V upon R. V is 5. R is 25/3. R3 इकडे येईल. So 5 into 3 upon 25. So this is 5. Therefore, this will be 0.6 ampere. So this is the current given by the battery. I is the current given by the battery or current drawn from the battery. So therefore, current drawn from the battery is 0.6 ampere. This is one objective question. This will be one objective question. Same question they will give they will give you same question आणि विचारतील how much is the current drawn from the battery. So this can be option B, or it can be A, it can be C, or it can be D. If this is B, then A can be 0.4. Okay, C can be 1, or D can be 1.2, whatever. Okay, so this is how objective question will be framed on first part of this numerical. फर्स्ट पार्ट वर असं न्यूमेरिकल विचारतील, सेम डायग्राम देतील and the current drawn from the battery. Question कसा असेल, in the given figure or even in a given circuit diagram or from the given circuit diagram, the current drawn by the battery or from the battery is A, B, C, D. Okay, so you have to calculate that and your answer is 0.6 ampere. That can be either A or B or C or D, whatever. Okay, so write down this. Okay, there was a doubt in question number 16. First, I will solve that question. Remember, whenever we have a cell, in that cell, we have two electrodes. One is this and the other is this. This is positive electrode, this is negative electrode. And the solution which we have is known as electrolyte. The solution is known as electrolyte. And when we connect some resistance to this, whenever we are connecting some resistance to this, then suppose I have this as point A, okay, this as point B, this as point C, and let's say this is point D, and here is some point E inside the electrolyte. So when the current is flowing, like this, then the electrons will be flowing in this direction. Sorry, current will be flowing in this direction. So like this, the current will be flowing. Current direction will be from this, like this, then it will come to this side, then go to this side, and goes to this side and this. So green will give you the direction of the current. Green will give the direction of a current, whereas opposite to that will be the direction of the electron. So when this electron is flowing through that electrolyte, when the electron is flowing through the electrolyte can be, it can be a salt NaCl, it can be acid HCl, it can be acid H2SO4, okay, it can be HNO3, different types of acids or bases depending upon the availability. So when the electron is flowing through the electrolyte, when electron flows through electrolyte, the electrolyte, the electrolyte gives, actually I will use simple words, electrolyte actually offers, gives some resistance, and that resistance is called internal resistance. It is known as, or it is called internal resistance. आणि याच्यासाठी जो सिम्बॉल आहे तो स्मॉल आर आहे. इट इज स्मॉल आर, इंटरनल रेझिस्टन्स. तर तो इंटरनल रेझिस्टन्स आपण कधी कधी ह्या डाव्या बाजूला, टर्मिनलच्या डाव्या बाजूला दाखवल्या जातो. So this is the resistance offered by the cell, and this resistance now 20 ohm is known as external resistance. It is always the one which is not, हे सगळे जे म्हणजे या ठिकाणी सुद्धा जे काय रेझिस्टन्स आहे हे सगळी एक्सटर्नल रेझिस्टन्सेस आहेत. They all are external resistances. Okay, and therefore the formula for potential according to Ohm's law, V is I into R plus small r. जेव्हा इंटरनल रेझिस्टन्स दिलेलं नसतं, इन दॅट केस इट इज ॲज्युम टू बी झिरो. आपण त्याला झिरो गृहीत धरतो. ऍक्च्युअली जो फॉर्म्युला आहे तो V इज इक्वल टू I इंटू एक्सटर्नल रेझिस्टन्स प्लस इंटरनल रेझिस्टन्स. कॅमेरे ऑन ठेवा रे, कॅमेरे ऑन ठेवा. So V is I into R plus R. तर ह्याला इंटरनल रेझिस्टन्स म्हणतात, इंटरनल रेझिस्टन्स. So it is the resistance offered by the cell, or it is the resistance offered by the electrolyte of the cell. आता किती आहे? V is given to you, that is 2. I we don't know. External resistance किती दिलाय? 20. Okay, plus 0.1. What is asked? A cell of an EMF 2 volt and internal resistance 0.1 ohm is connected to 20 ohm resistor. What is the current? अजून एक गोष्ट लक्षात ठेवायची. Whenever internal resistance is given, try to understand. Whenever internal resistance is given, त्या केस मध्ये आपण ह्याला फक्त पोटेन्शियल डिफरन्स म्हणायचं नाही, तर त्याला EMF म्हणतात. मी तुम्हाला ते पण एकदा सांगतो. ओके, जस्ट अ मिनिट. लेट मी एक्सप्लेन यू दॅट. EMF आणि इंटरनल रेझिस्टन्स हे जे सगळं आहे, लेट मी एक्सप्लेन यू वन्स. थोडासा डायग्राम मोठा करूया. Same diagram. Yeah, point pasun. This was point A. Let's say this was point B. This is point C. This is point D, and this is E. From A, when we move to B, from B, when we move to C, and from C, when we move to D. म्हणजे ए पासनं डी पर्यंतचा जो पाथ आहे that is known as external circuit. It is known as external circuit. And डी पासून ई आणि ई पासून बॅक टू ए, that is known as internal circuit. It is known as internal circuit. And together external plus internal circuit together is known as complete circuit. It is known as complete circuit. When internal resistance is okay. Now, fakta external circuit जेव्हा आहे, in that case potential is V. फक्त एक्सटर्नल सर्किट बद्दल जेव्हा बोलत असतील, इंटरनल सर्किट बद्दल, इंटरनल रेजिस्टन्स बद्दल जर दिलेलं नसेल, then potential is V. But when they are talking about both, external plus internal, then it is not potential, but it is EMF. I will tell you the definition of EMF also. त्याची definition सांगतो. And that is normally denoted by small e. Electron नाही. तुम्ही पाहिजे तर capital E न पण denote करू शकता at this stage. That is known as EMF. Okay. So what is EMF? EMF. It is electromotive force. It is electromotive force. Okay, but remember, it is not a force, it is a work done. It is a work done or the amount of energy required. Work done or amount of energy required to move the electron throughout the circuit once. Throughout the circuit means external plus internal circuit. Through both the circuit. That means for one complete round, when it is moving from A to B, B to C, C to D, from E, then back to A. Okay? A to B, B to C, C to D, from D it is E, and then again back to A. That is known as complete circuit. And the amount of energy or work done required for moving that electron throughout the circuit is known as EMF. It is work done or energy for moving the electron once throughout the circuit. आणि त्याला नोटेशन काय आहे? The notation is E. Notation is E. आणि फक्त okay, फक्त the amount of energy required, amount of energy required हे सगळं 11वी मध्ये आहे. Amount of energy required to move the electron through only external circuit, only external circuit is known as potential difference. It is known as potential difference and that is B. जो आपण ओहम्स लॉ पासून विचार केलेला आहे. It is only potential difference. So फक्त external साठी okay, you write down this first. अजून याच्याबद्दल मी थोडंसं सांगणार आहे तुम्हाला. When the circuit is from D to E and from E back to A, it is known as internal circuit. I told you this. And the potential difference between the two electrodes, the potential difference between the two electrodes is called internal potential. Yes, actually internal potential. In fact, this is the potential which is required for carrying the electron through the electrolyte. You can say energy required to move the electron through the electrolyte is called internal potential or another word, potential drop. Another word for this is potential drop, either internal potential or potential drop, and that is denoted by small v. That is denoted by small v. So therefore total potential, which is also known as EMF, that is denoted by E, and that will be external potential plus internal potential, and therefore this E external potential कसं मिळालं? So it will be from Ohm's law. So it will be I into R. Sorry, this is a small v. Small v. And this will be again I into small r. I कॉमन घ्यायचा करंट सेम असणार आहे करंट सेम असणार कारण नंबर ऑफ इलेक्ट्रॉन्स same number of electrons are moving through external as well as internal circuit, therefore current is same and therefore it is R plus small r. हा फॉर्म्युला आहे EMF चा. This is the formula for EMF. तर V चा फॉर्म्युला काय आहे? V is only I into R, external resistance. Small v चा फॉर्म्युला काय? That is potential drop. It is I into small r. I into small r. Write down these things. Okay. Now I will come back to this question. I will come back to this question. So what is given? Internal resistance is given to you, 0.1. And this, now this I will write instead of V, now I will write that as E. Okay, that as E. So a cell of EMF 2 volt and internal resistance 0.1 ohm is connected to a 20 ohm resistor. What is the current in this circuit? So now you calculate that. So therefore I is equal to 2 upon 20.1. 20.1. You need not calculate that. Need not calculate that. कॅल्क्युलेशन सध्या करायची गरज नाही. ऑब्जेक्टिव्ह क्वेश्चन मध्ये तुम्हाला कोणतेही एवढ्या पॉइंट मध्ये म्हणजे आन्सर येत नाही. ओके, यू कॅन कॅल्क्युलेट दॅट. नंतर बघा एम्पियर, करंट विल बी एम्पियर. ठीक आहे. सो दिस इज द फॉर्म्युला व्हिच इज रिक्वायर्ड. Write down this. Write down this. याचा आन्सर तुम्ही काढायची गरज नाही. ओके, कारण तेवढ्या पॉइंट मध्ये कोणी आन्सर देणार नाही, गरज नाही. तसं काढलं तुम्ही तर ते पॉइंट 0.99 वगैरे असं येईल, पण नो नीड ऑफ कॅल्क्युलेटिंग. कॅल्क्युलेट करत बसू नका, गरज नाही. फक्त त्याच्या मागचा थेअरी समजू द्या. क्वेश्चन नंबर 19 सोडवणार आहे मी आता. I'll solve that. Question number 19. Question number 19. Keep your camera on. प्रत्येक वेळी तेच. Question number 19. I will consider this as point A. I will consider this. Consider this as point A, this as point B, this as point C, this as point D, and suppose this as, or I'll consider this as B, this as C, this as D, this as E, this as F, this as G, this as H, and this as I. Okay. We'll consider the points like this. Now look at this. Look at this. When this current was coming like this, here it is getting divided, and it is getting divided. Okay, it was getting divided. So here it is flowing this way and this way. We will first name them. याला आपण R1 समजूया, याला R2, याला R3, this will be R4, this will be R5, this will be R6, this will be R7, this will be R8, and this is R9. This is R9. Okay, remember this one, these two are in series. Why? Because whatever the current is here, same current is flowing. Similarly, these two are in series, same current is flowing. So these two are in series. These two are in series. So this is 1, this is 4. 1 plus 4 will be 5. So from BCE, from BCE, we will get a series resistance of 5. Similarly, BDE, see, BCE will give you 1 plus 4, whereas BDE, that will give you 4 plus 1. Both will be 5. Both will be 5. But then both of them will be in parallel. I will draw the circuit. This is your R1. Then this is from B. This is from BCE. So that will be 5. And this will be from BDE. And again, they will be joining here at this point. Similarly, so this is your point now E. This was your point B. This is 5 ohm. This is also 5 ohm. Again, they are getting divided. Again, these two will be in series. Again, these two will be in series because same current. Same current. So that will be from FGI. This is F. So this will be how much? This will be how much? 4 plus 1. Then this will also be 1 plus 4. Okay. This was 1 plus 4. This was 4 plus 1. Then joining together here at this point. Okay. At this point. Then this is your point I. This is your point I. This was R1. That was 7 ohm. And then this is your cell again, which is 6 volt. Same circuit. Same circuit. त्याला अशा 3 लाईन दाखवतो आपण. याला म्हणतात equivalent. This is known as equivalent circuit. It is the equivalent circuit. आणि परत ह्याचे again we will draw the equivalent circuit of this. याचा परत काढूया. So these two are in parallel. These two, this one and this one, now they are in parallel. Similarly, this and this, they are in parallel. They are in parallel. Now I told you, whenever we have a parallel combination, so what I will get here? RP2 म्हणलेला मी. This I will denote by RP1. How much? Product upon sum. Product upon sum. Here also product upon sum. Product upon sum. Okay. So this will be how much? So RP1 25 upon 10. RP2 that is also 25 upon 10. This will be 2.5. This will be 2.5. So they are in parallel because the current is getting divided. So together because of this I am getting 2.5, and together because of this I am getting 2.5. So this gave me 2.5, this also gave me 2.5. Again I will draw a final circuit. That will be R1 as it is. Then I am getting 2.5 and I am getting 2.5. So 3 times. This is R1 which is 7. R1 which is 7. This is RP1. This is RP2. This is 2.5. This is 2.5. Finally connected to the cell. Finally connected to the cell. And the potential is 6. Here potential is 6. And now R1, RP1, RP2 are in series. They are in series. So RS, series combination, RS 7 plus 2.5 plus 2.5. That will be 12 ohm. Total final resistance will be 12. विचारलं काय? What is asked? Find the current drawn from the battery. Okay, so therefore current will be potential upon resistance, that is Rs. Potential is 6, resistance is 12, it will be 0.5 ampere. This can be an objective question. नीट मध्ये सुद्धा हा प्रश्न विचारला जाऊ शकतो. नीटच्या परीक्षेमध्ये सुद्धा विचारला जाऊ शकतो. So they will ask you, find the current drawn from the battery. This can be this can be option A also, or it can be B, or it can be C, or it can be D. Suppose आपण असं म्हटलं की this option is, let's say this option is C, then option A can be 0.4, option B can be 0.6, okay, option A can be 0.6, and option B can be 0.3, anything. Only this one correct option. Only this one correct option. So you first draw the equivalent circuits to me draw kara agoda. Draw the equivalent circuits. मी जे 3 सर्किट त्याचे ड्रॉ करून दिले ती अगोदर ड्रॉ करा. Draw them.